Afternoon, everyone. I get the privilege of filling in for Josh Boyce today, who is going to talk about platform engineering. So if any of you are not interested in open telemetry and ways that you can improve your observability, and you were just here for platform engineering, and there was another talk you were weighing up, feel free to jump out. But I quickly put this talk together today because I've got a few other talks, but this is something that I've been working a lot on, and I'm really, really interested in trying to improve observability, and I really haven't been happy with the status quo. Before I worked as a consultant at Arcana, I worked at 7 West Media as their tech lead, and we were using a couple of different APM products, but one of the products we used was a log ingestion product, and it's pretty common that you make a mistake, you get a massive bill, they then go, oh, well, we'll waive the bill if you add another 1-year extension on your contract. And also, if we were going to change it, there's a whole bunch of dashboarding and integration into our code bases that it's a really high investment of time and effort into your code base. So I thought I'd kind of go with something that is along the lines of platform engineering, and this is kind of what I came up with. So if people have questions, I'll be taking them at the end, so keep them in mind. But without further ado, I'll jump into it. Firstly, I wanted to go through the current landscape and kind of where I see what most people are doing and some of the trade-offs there. Where we've been for a long time is kind of text-based logs, where there's common formats kind of born out of the original web servers and operating systems and whatnot that log out requests, and that standard format allowed people to be able to read and parse text logs. Quite common as well is just like a level of info, warn, whatever, a timestamp, and then a message. These only take you so far, and you need tools to then turn that from a text-based string back into something useful. So we kind of built on that, and then a number of tools kind of came around and introduced the idea of structured logging, where your logs were an object. You could have attributes on them, like any sort of data, and they would have the level. These structured logs could be ingested by your logging tools, and you would then be able to go through using these log tools and try and understand what happened in your system based on these structured logs. It was really a nice step forward, but had a couple of limitations, and as I'm going through, some of these things might resonate with you. The other thing is we've kind of got all of these APM tools who are competing, and they're building these SDKs and ways that you can instrument your code base to kind of get all of this observability. So you've got Datadog from Azure, you've got Azure Monitor and App Insights, Sentry, New Relic, and there's heaps and heaps of these tools. Nearly all of them require you to go install their SDK and integrate it into your code base. A lot of these have some level of automatic integration and instrumentation, so you just install it, and then you get some level of observability out of the box. So it'll hook into your web server, so you know when requests are coming in and that sort of stuff. But how much automatic instrumentation is really dependent on which vendor there is. So the bigger vendors, they can invest more into their SDKs and broader ecosystem integrations, and so they tend to be better out of the box. But all of these still suffer from the fact that that is only surface level instrumentation. The best instrumentation that you can get is by writing it yourself. And if anyone's worked on a system where they have tried to put logging into their application retrospectively versus something that the team has agreed that they're going to do, use their logs to debug even locally, the difference between those two styles is massive. And so I'm going to be focusing on kind of the value of instrumenting your code with instrumentation that you own, not just relying on the instrumentation out of the box, though we'll be touching on that. So there's a few things that I want to touch on and reasons I believe that we're at a turning point, and OpenTelemetry was created. The first one is this idea of vendor lock-in. These SDKs are really hard to change. If you instrument your code with your business logic and being able to kind of instrument and get observability across business transactions, not just the technical execution of your applications, you tightly couple all of your code base generally to these vendors and their SDKs. That makes it very, very difficult to change, and it means that if one vendor has great market share and a lot of people using their SDK, it's a very sticky product, so they are not encouraged to kind of innovate on their product if they've already got this massive kind of market penetration. The next one is ecosystem integration, something that if you've worked in the .NET ecosystem, it's done really well. I spend a lot of my time in the JavaScript ecosystem, which is vast. I know many of these tools are build tools, so they're not actually runtime tools, but I only had so much time today to put together slides. This is a massive problem because if there's a new web framework or a new ORM you're using, most of the time you won't actually get integration into your observability tooling because that's not instrumented yet by whichever APM tool that you're doing. Ecosystem integration is something that is really, really, really valuable. So if anyone who here works in the .NET ecosystem, out of interest, quite a few. When I see people move between, say, .NET into like Node, for instance, there's this frustration if they're used to like plugging in app insights into their .NET application. That's like, I get all this stuff for free. That is a side effect of Microsoft is in a great situation where they own the platform, they own the language, they own the APM tool, and they also have this ecosystem where the majority of .NET users use Microsoft open source libraries as well. They use Entity Framework rather than the other open source ORMs and so on. So this basically means that you get this great experience, and Microsoft can make sure that any Microsoft team is instrumenting their libraries when they're built so they plug into this ecosystem. That's just not feasible in many of these other ecosystems because, especially in JavaScript, there is no really one big company that runs it. One of the best things about the JavaScript ecosystem is it plays in everyone's camp, so to speak. Because you've got PHP, you still need to run JavaScript, so you've got kind of the companies there. You've got Ruby, they still need to do client-side interactivity. So you've got these ecosystems with these big companies all playing in the JavaScript ecosystem, and so no one owns it. It's one of the most fragmented ecosystems because of that. And that means because it is so fragmented, you just can't possibly get this really, really nice integration and immediate observability with all these libraries because there's millions of them on NPM. The other thing that's really, really handy when you start working on a tool that is known by everyone is this knowledge that can come across between different jobs. I don't know how true it is, but I kind of heard these stories from Meta when they were open sourcing React and Jest. The cost of training new developers in the internal web tools at Meta was high because they just have so many developers. It was a really good investment for them to open source React, and then most of the JavaScript world gets to learn React. Now, any JavaScript developer or web developer that Meta hires already knows their internal framework. They basically made it way cheaper for them to bring new people in. That's another advantage of OpenTelemetry. Being in the Azure stack, a lot of the time using App Insights, for instance, the terminology is quite different. You're used to, if you're talking about observability, each product often has their own terminology for what they call traces or logs or metrics, and there's always slight nuances there. By introducing something that has a standard across all of these tools, now every single one of them is using the common terminology means a lot more of these concepts can move between your code bases and companies. Pretty valuable. I'll jump in now to covering a couple of major observability concepts that you kind of need to understand when thinking about these new observability stacks. Didn't grab my water out. So OpenTelemetry has three major types of telemetry built in. These are the fundamental building blocks and concepts that everyone needs to know when working with OpenTelemetry. The first one is traces. And this one's probably the biggest change in thinking if you're used to kind of structured logging. And while the change is very subtle, it brings about some really cool enhancements. So we'll cover them first. The basic idea of a trace is it is a collection of other events. So similar to you've got your log stream and you've got logs over time, you have traces over time. Those traces are made up of something called spans. So when we have a request come in that I'm getting the homepage, the DDD homepage, that creates a span. Inside that span, I can have a nested span. The way that works is all spans can reference a parent. So I load the current user's information. That is a span. Inside that span, it makes a call to the database, and that is another span. So you start building up this waterfall of traces or spans that make up the trace. Once you've got that, it goes on and loads some data, and you get this kind of waterfall that you can get a really good idea of what your entire request looks like. And while you can do this with logs, you have to build into your logging and the way you structure it and the conventions, everything to be able to make this sort of graph. So the way it works is we've got a couple of attributes that are key. The first one is all spans have a trace ID. So if you start a trace, it is allocated that unique ID. You then have a span ID. And you can see I've got ID 1 and ID 2. You can then have a parent. And all spans can also just have a bag of attributes on them as well. And this is really all there is to OpenTelemetry tracing is trace IDs, span IDs, parent IDs. And OpenTelemetry itself is a collection of SDKs that allow you to really easily author this, and also the specification. Because if we want to make open, like our telemetry open, it needs to run in every ecosystem, and every ecosystem needs to be equal. So all of these concepts will be exactly the same in the Python SDK or the Go SDK or the JavaScript SDK. All of these concepts and the way you use the SDKs, they'll be idiomatic to the language, but they will all follow the same kind of rules and architecture. If we compare that and go back to structured logging, our structured logs have timestamps instead. Has anyone tried to debug a problem with multiple services, and the services have slightly different times? They're out by half a second, and now your logs from service 2 are before the call that made them on service 1. The way you build that hierarchy up is using timestamps. Timestamps are just a lossy way of doing this and can suffer from servers being out of sync. Traces, on the other hand, are explicit. Doesn't matter if the time is different, you have an explicit relationship between the various traces. And the nice thing is, this is a well-documented context, the trace ID and the span ID. So if you want to cross a process boundary, you just need to pass the trace ID and the parent or the span ID with your HTTP request to another server, or include it in the message on the message bus. And now, when that message or remote call is done, it can pick it up and start appending new spans into that trace. Now you've got distributed tracing. And it's quite a simple model, but it doesn't matter if these are in process, cross process, or whatever, the model still holds. So really, traces are just structured logs plus a couple of key things. They have explicit dependencies between the spans to be able to create that waterfall without having to rely on timestamps. Spans have duration. That's a key thing. They have a beginning and an end. If you don't have a beginning and an end, it isn't a span in OpenTelemetry. So good examples of traces are function calls or requests or I'm processing a message. All of those things have a beginning and an end. And so the duration is a key aspect. They also are a container for other events. So you have plenty of things that happen in your code base that is more like a log. And in OpenTelemetry traces, they are called events. When we jump into the code, I'll kind of show you how it works. There's, in JavaScript at least, there's some really nice programming models that make this really, really cool. And we'll look at the differences between spans and events when we get into that. Talked a little bit about this, but one of the great things about this is this cross-process. So spans in OpenTelemetry have a kind. So anytime you start a span, which has associated start, you can specify the type. By default, that's a server span. If you're coming from, and often that will be things like a HTTP request. You then have an internal, and that's often things like function invocations. Then for distributed tracing, if you have something that is calling another system or raising a message, it is a producer because it is producing, it's doing something that will result in work in another system. And then when the other system picks up that piece of work, it is a consumer. And that's where you pass that context between the producer and the consumer. And now you have distributed tracing working in reality. So that was traces. The next key one is metrics. Metrics are quite simple. And there's a couple of different types, but I'm going to boil them down to 3. The first one is a counter. Counter, easiest example I can think of is the odometer in your car. It is just an incrementing counter, and you just want to make sure you know how many times a thing happens. This is really important because over time, if you're trying to scale your systems, volumes of logs are expensive. So often we introduce sampling in some form or filtering down. And when you first get started, it's very easy to just go, okay, well, I've got this log message that is logged every time this operation is done. I will just use my logging tool and count how many times I see that log. Now I know how many times it happens. Then you're like, ooh, I'm spending $10,000 a month on my log ingestion. Maybe I want to filter things out. And now your reports are not accurate anymore because you're not seeing all those logs. And that's where metrics are super important to do both logs, traces, or metrics. Every time you are doing an operation that is important to the business, just log a metric as well, or create a metric, then increment it, as well as doing the associated trace or event, because that way, in the future, when your costs start getting high, you can filter out your traces or logs without impacting your reporting. Next one is a gauge. Very simple example is your fuel gauge. You're going from empty to full. And finally, you've got a histogram where you are tracking how many of things in a bucket. So they're kind of the broad types of metrics available in OpenTelemetry. Finally, you have structured logging also, and this is very handy if you have a lot of logging already in your system. There are ways to plug OpenTelemetry exporters into your existing logging products. So where we've got this existing structured log message, pretty much it will add the additional metadata of your trace ID and your current span ID into the structured log, and it is the equivalent of a trace event in most regards. There's a few other concepts here that are useful to know. the way OpenTelemetry works is the SDKs, you use them directly. So similar to your logging framework, where you do an info level log, those are decoupled from where you're sending the logs. So in your tooling or in your code, you're logging, you're tracing, you're doing these metrics. You don't actually have to decide where any of that goes. The way you send your OpenTelemetry data to another process is something called an exporter. And so you will configure an exporter to App Insights or Honeycomb or Jaeger or any observability tool that knows how to accept OpenTelemetry data. So now that we've got through kind of a lot of the concepts, let's jump in and see what it actually looks like. So this is very, very minimal example using TypeScript and Node.js. I might just change this to a white theme. What? I'll just leave it. Is that good? Yeah, cool. Okay. Sweet. So there's a couple of things that we'll go through here. The first one is we talked about exporters. So you can plug in a exporter, and that tells OpenTelemetry where to go, where you want your traces, and this one's a trace. You can also specify your metric readers and log processors, which have their own exporters. But we'll just cover tracing because there's quite a lot to configure. There's different protocols here. So this one out of the box is the OTEL trace exporter, and you can install a package here, and this is a standard HTTP-based protocol. So any observability tool that understands how to receive OpenTelemetry data over HTTP can just put in this URL, they accept that data, and they will ingest it. There's also gRPC exporters, and then some other tools like App Insights, for instance, they don't have endpoints that accept OpenTelemetry data yet, so they have exporters that understand the internal structures of OpenTelemetry, and they will make API calls to App Insights in what App Insights is expecting. The next part of OpenTelemetry is something called semantic conventions, and this is a whole bunch of different attributes which are standardized. Part of the problem of structured logs is you end up with all of this data around like request IDs and whatnot, but it's arbitrary. So you go from one system to another, someone's called it request ID in one system, someone's called it correlation ID in another system. Now you're logging across these systems, you have to work out how to bring all of that back together, map different attributes to each other, and it's a bit of a mess. So a large part of OpenTelemetry is semantic conventions. Keep hitting that. Semantic conventions, which are specified names of these attributes, and you use them across all of this ecosystem. So if you have a look at a HTTP server in Go or Python or Node.js or ASP.NET, the attributes that are coming out in your telemetry data will be exactly the same for request start time or end time, and all of that stuff is actually specified via OpenTelemetry. Very, very handy. So the next part is you have this SDK, and part of the SDK, we talked about like ecosystem integration. In here, you have something called instrumentations, and this is where this community of instrumentations exists. There's currently about 800 community instrumentations for Node.js, I think, and they are install this NPM package and configure the Express or Remix or Prisma or Drizzle or whatever you're happening to use, whatever your library, install the community instrumentation, and that is all you need to do. And now if you're using, say, the Drizzle instrumentation, you can just plug that in, add it to here, it will automatically hook into all of the database calls, and now you get observability for every time you make a database call. Very, very handy. And then we talked about just the ease of getting started. There are also auto-instrumenting packages like this one, where I can just say, go auto-instrument my app, and you can have a look here. Oops. These are all the different out-of-the-box libraries that it supports. So it's just a collection of a heap of instrumentations. And so just by turning that on, for example, if you're using fetch, you will automatically get all of your fetch calls using node fetch instrumented. You can hook in and configure bits and pieces. So I can just say, I don't want this auto-instrumented, and turn it off. So that's kind of shows the power of this community, and anyone that's building an open source project can, or if you're using a library that doesn't have instrumentation, you can go and instrument that library. They've got a whole bunch of tooling that makes it easy to instrument any open source library. And the way it works under the covers, we don't have time to go into it, but essentially you just patch the exports so it can hook into all of these different functions, and it has a heap of tooling around making that really easy, and patching the correct functions for different versions of the application. So that's pretty cool. Now a whole bunch of different companies don't have to build the same instrumentations over and over and over again. Now we're going to get into kind of how we started Trace. So here I go start active span. They've put a lot of effort into the span propagation, and you'll notice here I can go span.add event. That will add my event onto this span. Let's just introduce a function. So I'm not going to pass in the child span. Instead, I'm just going to go function. Oh my God, can't type. And I can actually go trace trace.getActiveSpan, and then I can add another event here. I can also just go tracer.startActiveSpan. I'm just going to add another child event. So I'm going to create a child operation here. You'll notice that I'm just going tracer.startActiveSpan. I don't need to go find my parent span. They are using the SDK in all of the different languages, uses whatever's available to propagate context. So inside Node.js, there are async propagation tools where you can just attach arbitrary metadata to the current call stack, and they're leveraging that. So you don't have to pass your logger around and remember to pass the current span. All you need to do is just make sure that you use these functions, start active span, and then it will create a child operation and automatically associate it with the current running parent. So it's kind of a lot of black magic that exists in all of the SDKs, and at the end we'll just shut down the SDK. But if I run that, I'll jump across back to my browser. Here I'm using a tool called Jaeger. Jaeger is a Docker, just a Docker image that is an open telemetry tool that has the standard open telemetry endpoints. So I can just point it at Jaeger, and you can see here, I'm just pointing at localhost v1 traces. There's no auth or anything, but these endpoints are standard. So if you're using Honeycomb, you can just point at the Honeycomb OpenTelemetry endpoint, and then also just another environmental variable for the API key, and it will know how to pick that up and send telemetry to that exporter. So if I now run this, you'll see that I've got my demo operation, and I've got my demo operation here. If I expand it, I've got my logs, which is the different events, and then I've got my child operation that has automatically built this tree. Really, really simple. But if I do want to do kind of the distributed tracing thing, when I'm creating a span, we talked about span kinds. In here, I can go span kind, and this is a producer. Inside here, you've got a span context, and the span context contains the trace state and trace ID and interesting things. If I was sending a message to another system, I just grab this span context, store it as metadata on that message. In the other system, I would read that span context off, and then I would associate here, I would change it to span kind consumer, and then you can link it to so you'd just be able to link it as a child consumer, specifying whatever metadata is there, and then you get the distributed tracing across those. So what we'll quickly do is, this demo isn't as rehearsed as I would like, apologies. So we're going to just put the span context up here. This will be a producer. I won't link anything here. It'll get the span context. Here I will go remote operation is the consumer, and it has the span context there, and then I won't worry about that. Okay, so now what I'm doing is I'm starting this child operation. It's producing a message, which then pretend this is in another system. It is a remote operation. It's picking up that message. It's explicitly linking to that existing span context that I've passed across the process boundary. So we'll have a look and see what that looks like. Oh no, what have I done? Sorry? Oh, that's good. Yeah. So used to TypeScript. Thank you. Okay. So if we jump in here, you can see that this has references off to other processes. So it is referencing this reference type follows from. This is really confusing. Yeah, so the remote operation here is linking across. Oh, that's weird. I've stuffed something up. Anyway. Okay, I know what I've done. Because of the context propagation, it's making it a consumer and it's also a child, so it's linking and it as a child. So the way to break out of that is you can say this is a root span that makes it its own independent span. Basically, it is a span that has no parent. If we run this again, hopefully we'll see some outputs that make a bit more sense. Okay, cool. So now we see our demo operation and our remote operation. If I jump into my remote operation, it has a reference saying I'm referencing a span in another trace because they're independent, and I can jump across and it shows me my trace in my other system. So pretty nifty, doesn't require a heap of work to integrate all of that stuff. Okay, so that's kind of a bit of a run through of OpenTelemetry traces. I don't have time to go through metrics and logs. As I said, the logs API looks very, very much like the loggers that you've used in the past. The main difference is they use that context magic to associate the log messages as events. So why should I care about all of this? We've talked a little bit about kind of the benefits of trying to consume these things and invest in open telemetry, what could that actually bring us? I said that I'd try and tie it back to platform engineering a little bit, and this is where I can do that. So one of the things about platforms is ideally it's about differentiation. Gregor Hope talks a lot about what you can get if you remove constraints from your business, and that's what platforms are trying to do. They are removing constraints and allowing you to focus on things that are not kind of mundane. Like, I don't want to be investing in how to build my web server, how to do telemetry, how to talk to my database, how to do backups, all of those sort of things that require effort from every person, like every team building every product. If you remove those constraints and allow people to get to a higher baseline to start with, it means we can differentiate more. Each of these APM tools, like New Relic or Honeycomb or App Insights, if they're not investing in their SDKs and spending heaps and heaps of engineering effort trying to integrate into Next.js and Remix and the next web framework that's come out, now they can spend more time building what is actually something we care about, which is, I'm sending you all of this telemetry data. I'm working really hard to instrument my application. I want you to tell me what's wrong with my application. So it allows them to really differentiate. Building the SDK is not a differentiator. And this is why all of these companies are on the board of Open Telemetry and are contributing to Open Telemetry. So yeah, it's a shared investment and it's a platform, because now we don't have to worry about SDKs, we don't have to worry about the collection and sending side of telemetry. Now, and even the receiving side is standard, which is great. Now all of these telemetry providers can worry about making their products, which is understanding that telemetry data and differentiating on that. So that's kind of the platform angle, and really, I don't think we've seen what our telemetry products can do, because we've spent so much time on this hard problem of getting the telemetry data in. Hopefully we'll start seeing some really interesting areas of improvement. So what are some next steps for you? Adopt it now. Try and start using it. Pick up tracing over logging. One of the things that is interesting, and you might come across this, is you'll notice traces. I didn't have log levels in any of my traces. Now, this is because tracing generally gets sampled at the root level. It decides that it is going to sample that or not include it, and then everything in that entire trace is discarded. So there's two styles of that, head sampling and tail sampling. Tail sampling is really, really good, and it's the better form, because I can look to see if that span has had any errors in it, and then I can choose not to sample that. Head sampling means that you make the decision to sample it at the very start of the request. What that means is you might have a 500 in your web server, but you don't end up seeing it because you've made the choice to not trace that at the beginning of the request. So there are some differences, but the models and things are kind of the guidance is out there in the Open Telemetry documentation. So start using tracing now. It will level up your observability far more than just relying on logs. And that's it. I'll take a few questions.
Two questions. How about a round of applause while we...
Do you have any recommendations on what you've seen a good rate for head sampling for? Because yeah, obviously, like when people look at tutorials and stuff, like it's always like 100% and.
Yep. So the best one I've seen is from the Honeycomb folks. I think the product's called Refinery, and it is a service outside of Honeycomb that you run separately. And essentially, what it does is it buffers the spans, applies the logging, and then or the rules, and then forwards it on. That one's the only kind of one that comes to mind around a separate product. But the challenge around tail sampling is normally, if you've got a lot of requests, keeping all of that observability data in memory can be problematic. So that's why Refinery is a separate product, so you can send it and then it makes the decision.
Yeah, sorry. So that's talking about tail sampling, but for obviously because head sampling, you need to there is a cost for your application to generate record that span and ship it. So from the actual application, the entry point route, the ratio of how many requests they will decide to record a span for. Have you seen some good ratios of 1%, 10%, depending on?
Not really. It really depends, because I guess the question there is, have I seen really good recommendations for head sampling? And not really, because the challenge is it's lossy there. So if you don't have, say, good use of metrics, it may not be good for your business to be able to throw away failed requests and that sort of stuff. So yeah, I haven't really seen too much in that space.
I'm curious about, you mentioned when we were logging you had timestamps that potentially if you were working across distributed systems, those timestamps wouldn't sync up with each other. I was wondering, I didn't quite get how that was solved with distributed tracing, because it seems like when you're drawing, I guess, a span, you've got a start point and an end point that kind of is represented probably by a timestamp, so it started here and ended here. And if you had a distributed trace, those timestamps could still be out of sync, and you could have a span start before, relatively before even the root span did.
Yep.
How is that actually solved with distributed tracing, or is that still a problem?
Yeah, so if you have a look and let's take the sample that the second system is running a couple of minutes, or a minute behind, what you would see in your waterfall is your parent span, and then you would have a child span because of the parent-child relationship, but that child span would start before in terms of time, but it would still be a child that had a start time before the parent. Does that make sense?
Yeah, so it sounds like you solved the problem of being able to link it together, but still it would display weird because...
Exactly.
Yeah, okay.
Yeah, and then I think that's where hopefully the differentiation of the tooling, Jaeger out of the box will tell you that you've got clock drift because it's not doing it, and some products may choose to ignore that and just line it up because that makes logical sense.
It sounds like there could still be nuance where you've got a bunch of services talking to each other and they happen in sequence, but one kind of displays before the other when in reality it was actually after the other because of the timestamp drift.
Yeah, definitely. And I don't know how you'd possibly get rid of that, but at least it knows, and the tool, the APM tool, could make it clear that that was an impossibility somehow. That's a good question.
Just a quick one. How are the logs, newbie question, but how are the logs related to the traces? Are they treated like trace events? Yeah,
pretty much. It's a separate API, and it is structured in the same way that you'd expect with levels and basically those semantic attributes that you're used to having logs. You just have more of those semantic attributes that look like a log, but it ends up being essentially an event. And it totally depends on the tool that is receiving it, because the trace endpoints and the log endpoints are two different endpoints, and so different tools could choose to display logs separately to events. So that's actually now a product decision more than the tool. I think that's about it for timing though.
It is. Thank you so much, Jake. It was fantastic.